Hey, it's Mr. Allred. I'm here to work through practice problem 3, the solution from linear equations. The problem was the fraction 4z minus 3 over 2 plus 3/8 equals the fraction 8z plus 3 over 4. And starting off here, the first thing I asked you to look for is fractions, and we see them. So we see fractions. And we want to find the least common multiple from those denominators, which are 2, 8, and 4. So the smallest number that 2, 8, and 4 will all divide into is 8. So we're going to multiply our entire problem by 8. So that's basically a distributive property. So we're going to say 8 times 4z minus 3 over 2 plus 8 times 3/8. I got my color off there, but it's okay. Equals 8 times 8z plus 3 over 4. And if you're having trouble seeing where that came from, we're taking this 8 and we multiply it by the first fraction, the second fraction, and the fraction on the other side. So we multiplied everything by 8. So in this process, we're going to clean up. So I'm going to do a couple things here. The 8 over the 2 would be 4, so I'm taking baby steps here for you. So that reduced to 4, so that 4 would be times 4z minus 3. Over here, this middle fraction, 8 and 8 cancel out, so that will just leave us with the 3. And on the last one, the 8 on top and the 4 on the bottom will reduce to 2, which will be times 8z plus 3. Now, you might be used to doing several steps at one time, and that's okay. But we no longer have fractions because we picked a multiple that all of our denominators would divide into. So whether we did multiple steps at one time or not, the way I have it written, we are at where we can use a distributive property to get rid of those pesky parentheses. Okay, and we have two of them. We have the 4 multiplied by the 4z minus 3. So we'll go ahead and write that out. That one will be 16z minus 12. We'll bring the plus 3 down. And then we also have on the right hand side the 2 outside the parentheses, which is times the 8z plus 3. So we'll push that in and we'll have 16z plus 6. And my next step, if I've done everything correctly, is I usually like to combine like terms. If it's a linear equation, then that means there'll be no more than 2 terms on each side. The only combining I have here is the negative 12 and the 3 on the left-hand side. You may see this as trivial, but that's fine. 16z negative 12 plus 3 is negative 9 equals, and on the right-hand side nothing combines, but it'll be 16z plus 6. So you can do this one of 2 ways. You can go ahead and jump to the step I like to do, which is I call add subtract across the equals, where I try and get all my z's on one side and my non-z's on the other. So I can see that I would want to move 16z, so I'll subtract 16z from both sides. Now I can either notice that that's going to get rid of all my z's and leave me with negative 9 equals 6. If I'm not paying that close attention, I might add the 9 or subtract the 6, but I will still have 2 numbers that really don't equal. So the point here is negative 9 does not equal 6. And if you go back to the rules I said, if the variable goes away, you look to see if those 2 numbers are equal. They are not, so this is a contradiction, which sometimes we might say no solution. And that means that we cannot find a number that when we go way back up top and look at the two z's in this problem, there's nothing we can put in that place for z that will make this equation true.